My name is Iulia, by the way. I work at Elastic. I'm a community advocate, specifically in Amsterdam. So I'm usually the host of these events that we have every month together with my colleague, Adrian, who's working remotely. And we organize these quite often. And I also do like different conferences on behalf of Elastic, mostly specializing on Python and the AI ML space within Elastic and what we can do with that. So that's why this talk also made sense for me today. Part of the session is also what I have for like my running conference speech. So it's been used before. It's not brand new, but then hopefully means that I will make mistakes today, especially with the live demos, which we all love. So I'm starting with back in my day, which might be weird because I'm not that old yet, but it does feel like it because the field has been changing so quickly in the past few years. And what I mean by back in my day is back in 2018 when I was doing my bachelor thesis. And that's when like the first time word2vec started being a thing and NLP, like natural language processing, was coming around. And it was really cool. And that's what I decided to write my thesis in. And it turned out to be a pretty good choice because then it kind of blew up. So it's been quite fun to see what it became since the beginning. As you can see in this illustration and many others like it all over the internet, it's kind of exploded into this massive thing that came into the media lately with the whole GPT craze and generative AI and all that. But really what it started with was around 2018 when we first started to look at sentences as data and like what we can do with that in a cool way. Specifically, word2vec and Glove were like the cool kids around. That's what I worked with as well. And fast text, I didn't personally touch, but you can see how from this one branch, we got to where we are today. So what was actually cool like 5 years ago and what were we doing with that? Oh, this is my thesis, so you know I'm serious. How did it all start? And if you know me by any chance, you might know that I try to get Harry Potter into every single one of my presentations in one way or the other. And I think it's a really good example because the Harry Potter books are books, but we look at it as data. Usually when people say data, they think of Excel sheets or they think of tables. But when we talk about LLMs or just working with natural language in general, this is the data that we refer to. Just the sentences and the words and the characters and the letters, and we can do cool things with this. And the thing that I keep going back to is this fake Harry Potter book that got created in 2017. So again, back then, this was like so mind-blowing because it was generative AI, but yeah, quite a few years ago, where they put into a model all the Harry Potter books and they got a new one written in the same style that was called Harry Potter and the Portrait of What Looked Like a Large Pile of Ash. Wonderful literature for everyone to read. It doesn't make a lot of sense, but it kind of uses the same words and it kind of sounds as if it could be the style of J.K. Rowling, but it wasn't really great. It was just like a joke that people had on the internet. And we didn't know that it would become what it has become today. But that's kind of the example that we'll use throughout. And we also have a demo part at the end of how we use it with Elastic. And I've built like the whole model around the Harry Potter books. So you'll see how they translate into vectors. So before we do that, what are vectors? Some of you might, of course, already know. Apologies if I'm simplifying it a bit too much, just to make sure we're all on the same page. You might have had vectors in math. Again, when you see vectors, we think about multi-dimensional space, but we think about numbers, right? You have 1 in the x dimension and 2 in the y dimension. It's a 1-2 vector. When you have 3 dimensions, you have this like list of coordinates basically in the brackets. Those are 3D vectors. When we deal with the embedding space and the vector space for natural language, we're talking about much, much bigger vectors with many more dimensions. Like the human brain can see 2 and 3 quite easily. But if you add 4, it's getting kind of difficult to visualize. And then if you have like 1,000, it's not very nice to display, but that's kind of the base principle of it. And then how do we go from the Harry Potter books to words, to vectors? We call that bag of words. This is like the most basic computation to go from a sentence into a vector. So you can imagine that we have this vocabulary of like these, I don't know, 7 words, whatever they are. And then in each sentence, it can either appear or not at a certain position. So the vector form of this could be, you know, you is in this sentence, but it's not in the second one, and so on. We have A that appears in both sentences. We have Harry that's just in one, and so on. Like you can represent, you can come in. You can represent sentences in a vector space in this way, like as a sparse vector. But of course, this works because we have a limited amount of words. But if you wanted to put the whole book in a vector representation, that would again be a very, very long vector, or you have to find a different way to do it. Then what also helps about vectors is that, you know, they're directional and you can use them to compare different things. So we can decide what the dimensions mean or attribute them meaning. And then we can like create our own axes of how we interpret these dimensions, right? So we have on the Harry Potter scale, we could have, you know, like wizards and muggles and magic and cake, I don't know, whatever you want to have in there. Then within the vector space, you can kind of relate these words to each other and figure out where they stand. And that's the basis of doing cool stuff with NLP later. So it gets, you know, again, quite complex. But again, this is in 2D. Imagine this with like a lot of dimensions. This is the best representation I have. Yeah, it's not very helpful. So what is a model, right? We have the vectors. Now we want to do stuff with them. And usually the models look like this. Maybe you've seen these graphics as well. Like whenever we talk about deep learning, we talk about perceptrons or neurons, or what we're trying to do with deep learning is kind of interpret the way that the human brain works with the synapses and the neurons and the connections between them. And we try to kind of use the same language. Of course, it's a lot more simplified than how our brains actually work. That's why we don't really have AI, but it's just a way of learning how to process information and how to store it and link back to it. And then somehow we know that a cat can be represented in a certain way. So this is kind of what the models look like. And what this fits within, you know, what you might be familiar with. Within this field of ML, because machine learning just means, you know, a machine is learning to get better at recognizing a cat or at understanding the meaning of a sentence. But within that, transformer models, or, you know, these are the kind of, NN means natural neural networks. Complex models that work with really, really large data sets, which you would really train on your computer. You would have Google do it in the cloud somewhere, or whatever organization, for years and years. And then within that, like the most specialized thing that we're talking about today are the large language models. Because like you've seen earlier, if you have 10 words, it's already a big vector. If you have the whole vocabulary of a language, it gets really, really big. So you need really huge processing power to deal with all of that. And why is that relevant to Elastic, which is where you are today, and why are we talking about it? I mean, of course, everyone can talk about LLMs these days because they're just popular. But Elastic is actually a vector database in itself. So it started as a search engine, of course, but in order to search through text and through sentences, we use vector databases, and we use what you'll see later, which is like vector similarity. So we have a sentence that comes in, or like in your documents, in search results on Google, whatever you're looking for, we embed it into a vector representation. This is a dense vector. As you see, we have like different values in there, so it's a bit more complex than just 0 or 1. If a word shows up, we have more dimensions. And then what we do when we want to search for something, we have that representation. How that works within Elastic is we get different external third-party models that have been trained. Like I said, you know, those really big, heavy models, they get trained somewhere and then they're readily available. You can just plug them in and apply them to your data. So we're hosting them, and we're able to run, you know, ask questions to those models without having to build them from scratch, or without you having to build them from scratch in your own projects. So that's how that works. And we have quite a few things that we can do with that, which I will show again with Harry Potter. There's different things that LLMs can do, right? LLM also means quite a few things. It means sentiment analysis. Is this sentence positive or negative? Is this sentence about cake or about war? Quite different. What is the keywords in this sentence? Can you summarize it? Can you make me a sentence with a happier tone? All these different types of questions. are different types of large language models. And you can kind of use whichever ones you want or combine them as you see fit. So how do you do that then? We have the sentence, it's a vector, okay, all our sentences are vectors, then what? Well, because vectors are math, it is a lot easier to also compute different differences between them. So if within the same vector space, right, so we manage to have all the sentences in the same context with the same language, then we can see if they're like similar, unrelated, opposite, and using those distances, then we can create these searches if I'm looking for something similar or the opposite of my sentence. And again, to go back to what was really cool, like a few years ago, our minds were blown that you had like this representation in a space in which you could do subtractions between words. So you would say king plus man minus woman, and you would get queen, and you would be like, how does it know? Like that's such a human interpretation of those words. And it's hard to express that it was really cool back then, but now you've all seen what ChatGPT can do and you think it's really lame, but it was really impressive. And this is kind of the basis of how we've been evolving from there. And now you can use different kinds of language, but just try to think that, you know, this is a way to see those words relationships. But you can think of, is walking and walked related because they're the same verb with a different form, or is walking more related to running because they're similar kinds of actions, or is walking related to waiting because they look the same as words? It's very difficult for the computer to really process those differences, and that's why it took us quite a few more years to get to where we are today with ChatGPT. Yeah. In the end, it looks like this. We look for queries. What does walk look more like within the context of my project as well? And then we get cool stuff. So to summarize kind of in an architectural picture, what Elastic does, or what engines that work with vector databases do, is we take these documents, whether, you know, it's not tables anymore, it's images, it's Harry Potter books, it's audio files. We convert them into a representation as a vector, so we're all in the same language, like no matter what data we have, it's all within the same parameters that we can compare it to each other. And then we look within our database of other sentences and try to see, you know, what's similar. Can you like represent this sentence in a different way? Is this the opposite of the other sentence? And we can do math with words. And now for the example part, like how does this all look like in more simple terms? And this is the session that I give quite often at different events. And we're gonna show you how that works. So first of all, if this Google thing went away, we have Elastic, which, yeah, if anyone is here just for the LLM part, quick intro, Elastic does, you know, search, observability, security, and other such things. But I think most people know it from search. Observability, it just means you can make visualizations. So for example, I have different dashboards, and I made like a Harry Potter dashboard here. Yeah, it's like every other visualization tool, but the data you put in, you could have it be interactive, so I know like what class, what house the people are in, and things like that. But what Elastic mostly shines at is the search aspect, right? So if I select my Harry Potter database, every single entry is a document. You can still see them back there. And you have all these features from different people. Like this is quite a simple database as an example. And I can look through it and say, I want to find people whose eye color is blue. None. Okay. How about blue but done correctly? No. How about blue with a capital B? There we go. So this is a great way to show that search can be difficult when you just have like the basic search. You might have experienced this before as well. Like if you misspell a word or you don't capitalize and add quotes because you forgot to do it, even though you give this demo every day, it doesn't work, right? So we need to do better than that. And that's what we've done with LLMs. This was totally on purpose. So you can also add more things, like, you know, you say, I'm just going to keep trying. You have eye color is blue and gender is female. Also works. And then, our results narrow and so on. So you can make pretty complex searches with that, but still it's only as good as each individual search works. And if you mess up a word, it doesn't work so well anymore. And how does this work if instead of, columns and values, we actually have sentences? All of a sudden, it's like even more confusing. So what we do is we can start working with code to make this work, since it's a little bit neater. And like I said, I prefer to use Python. And what we can do is we can just connect to a Elastic instance, and we can run these queries just from our own code. It still works, and we can print different results. And if we're working with code, we can also, make them look a little neater than those big columns and JSONs and whatnot. But what if, like I said, I want to work with language? Then I have this extra database that I've created, that I have the model that I want to use. Like I said in my presentation, we can import models from third-party applications, specifically Hugging Face. So I'm getting a model in for first sentiment analysis, making sure that the model is in there. And then what I can do, if it works, is I have a sentence and I can decide if it's positive or negative using a sentiment analysis model. This is something that I can then include in my search later as like an extra feature. So you can see that we have a little sentence there, and we make an inference result. So basically we ask a model, what do you think about this? And it tells us what the sentiment is. But then we apply this to our entire data set of the entire Harry Potter books. So then the results are all the different sentences get analyzed. And then we can say, okay, give me the most negative ones, for example. And these are the most negative sentences in the series by the computer comprehension of what negative means. I have them on the slides as well, just so it's easy to read. The most negative sentences in the book, as seen by the computer. And then, of course, we have the most positive sentences in the book, as interpreted by the computer. And these are like way more human type of searches than looking for eye blue while misspelling it. So it's quite, a step forward in terms of what we can look for. And then what we can also do is, once we have the sentences, if we embed them into the vector space, like we said that we could do that before, then basically we get the model in, and then one of these sentences then becomes this really big vector with a lot of values, right? So the same sentence that I was checking before, if it's positive or negative, becomes this vector representation that I don't really understand, but the computer does. And if all the sentences start looking like this, then we can compare them as well. So I'm applying this to all my data, and I've selected a few sentences that I can now, try to see what's similar to that. These are the few words that I've chosen. Would you like to try different words? Just as a...
Can you do the same thing with the blue and the gender? Right?
Yeah, like blue eyes. You can look at that. So right now we're just like comparing this as a vector versus the rest of the books, or female. What is that going to work? Just doing a few at the same time with this function. And then we get the results. So blue eyes was here. We have Harry saying, my mother's eyes. I am rabbit, probably some potion ingredient. I remember seeing a pair of great big yellow eyes over there by that sink. Close your eyes, and other such things. So maybe in the books, no one specifically has the words blue eyes, which again, if we were just searching for blue eyes, it would have exploded. But this way, it sees that, okay, I have other kinds of eyes, or eye, which is not plural. Close your eyes, and etc. And for female, it sees the woman is the same thing as female, and ladies, and girl, and gentleman, which is in the same type of characteristic as woman. So adding this embedding space really helps your searches become more human. And then why did I show you the whole sentiment thing before as well? Is because we can actually combine these, and then you get even one step further when, well, I'll just show you the slides since it's easier. So if I look for what do they fear, for example, just putting in the embedding space, this was the prompt, and the responses were, yeah, we see fear coming up, we see danger, angry and scared. So it's already, you know, kind of cool that it can see those different synonyms. But then if we search for brave, we see brave, courage, whatever, same example. If I tell you I want brave, but I want it to be negative, then all of a sudden the brave turns into risky and fear and coward. But fear shows up quite a lot of times. So I'll tell it, you know, do brave and negative, but exclude the word fear because I want more variety. Then you get, well, fears is still in there, so you tried, but you get afraid and risk and coward. So all the time, yeah, you get more close to exactly the kind of sentence that you want to see with the different dimensions. So yeah, that's kind of how that works. Again, this works because we're using vector databases, the representation to get everything in the same language. We're using ML, which has the ability to learn how to interpret those vectors and what the relations between them are. And we're using search, which already is like a very fast optimized way to go, I have this vector and compare it to all the other ones, but like within a second, because I don't want to wait because I'm using the internet. So that's how Elastic works with vector search and with LLMs. Nice shiny overview slide to end with. But yeah, I hope that cleared up some idea of what LLMs are and what you can do with them in a toy project kind of way. Which, to be fair, I feel like what most people do with LLMs is just like funny little examples, and you more rarely see it implemented in an actual business case, which is why we have Zen over today to show us how you can also use it for business and not just cool magic tricks. Any questions or still things you're not clear on?
But so you vectorize the data,
yeah,
and you vectorize the query,
yeah,
and you do the similarity search. What is the part that Elastic helps? I can use any database like Cassandra.
Yes, you can. So the kind of similarity that we do is not just like comparing the angle between two vectors. Of course, it's a bit more complex than that. And the model that I used for that was ELSER, which is our own like semantic search kind of technology. If you're just doing vector comparison, then yeah, you could do that with the Python project easily. What Elastic does is it's a search engine, right? So it's very good at adding those different types of queries. If I say I want this and I want to look at excluding this term, or I want to look at filtering the results in this way, then yeah, you're searching. And this is like more features that you can use for that search. If you don't need those features, then yeah, of course, there's no need to use it. That's perfectly fine. Usually we have people who use search within their documents and want to add AI, or they want to add different functionalities to it. But where I'm coming from, which is probably where you're coming from, if you know you've worked with Word2Vec before, then Elastic is something on top of that if you want to dive more into different type of search features. So yeah, depends what you want to compare.
The model you used for your embedding, that is like publicly available? Or?
Yes. Some models are free to use and some are not. I know that like some of it is you need a premium subscription of Elastic if you want to run with it. But if you just take the external models from Hugging Face, like you can take your own embedding model, you can take your own comparison model and build it together. But Elastic also has like a all-in-one just deploy thing that is part of the subscription model. Sorry, go ahead.
Does Elastic also have functionality to help you with like changing the position of the vectors relative to others? So for example, like let's say you're using more of a financial context and default should mean that someone doesn't pay their loan versus like being the regular way that you set something up.
Yeah, so there's a lot you could do with what we call RAG, so like retrieval augmented search, which allows you to decide, you know, on what documents to use it, and also with financial services you mentioned, is you don't want to send your data to an external model. You want to first have Elastic look for relevant stuff internally, then decide what to use the model on or like what data to hide. So there are quite a lot of features you can use on that, on how to use certain LLMs in your way.
Okay, thank you.
You wanna... Oh, yeah.
Yeah, I have a question. What I heard was about like embeddings, vector databases, similarities, and so on. What was the LLM part which you are leveraging and using to enhance your service?
So that's why I was hoping to explain that LLM just means large language. So anything that has to work with interpreting sentences is an LLM. So embedding, like embedding models are LLMs. Sentiment analysis models are LLMs. All of them are language models, but we kind of throw that word around to mean like a very specific, like generative AI usually idea. But any part of machine learning that's like a very complex model, so deep learning, and has to do with language is a LLM. So that's kind of, yeah, that was why we were using LLMs, but yeah, I'm not generating new language if that's what you were expecting. Or
I guess I got my answer. Thanks.
Do I need more server resources to do that? So basically, I would do a classic indexing using Elastic. So if I want to take benefit of the large language model, how do I glue it together?
So we don't train our own models for that case, because most people probably wouldn't want to spend the resources on that. We just take models that have been trained and use it for inference. So you can take a model from Hugging Face, for example, and just add it, and then you can reindex your data. So as you reindex your data, you embed all your sentences, or you analyze all your sentences for a particular type of activity. Or you can have a pipeline that as new data comes in, it gets analyzed through that lens as well. So you either have it for new projects, or your index that you already have, you can pass through it as well.
But after I've done that, the cost of the search is the same as if I was using a normal index?
Yeah, it's just an extra like criteria in your search. You can say, I want to search using embeddings dimension as well. You just add it as a parameter.
One more small question. Do you support clustering?
Clustering?
Like if I want to cluster a query, is this something that Elastic can help me with?
I think so, if I understand it correctly. So you have like nested queries, you mean, or?
I'm not sure about nested queries, but let's imagine that I have several different documents, which in the vector space, they are pretty close to each other. So I can imagine that they are a cluster. So I have a new thing that I have a new query that I want to put it in your database.
Yeah.
And easily just get if it's in the cluster or not, instead of receiving for example, 5 closest documents to it.
Yeah, I mean, I don't think it will tell you where the clusters are, because that's something that it kind of does internally. I'm not sure if you would be able to visualize how the model organizes its data, rather than just saying, yeah, what are some similar elements to this, or are these similar or not? So in that sense, no, it wouldn't explicitly tell you what cluster it's in, but it would know to add it next to the other ones in its understanding of where they go.
Okay.
Hope that was clear. We can talk about.
Yes, it needs.
And yeah.
Yeah, so is there a link with the, or no link probably, with the Affen or Suzette, I think they're called like that, sentiment dictionaries?
Sorry, can you?
So there's like the sentiment dictionaries, which have like a scoring system. And is there any link with this model with those type of dictionaries, or not at all?
So the models are just on Hugging Face. There's different ones you can use with different types of sentiment analysis. So you can choose one that works in the way that you want. I'm not familiar with the dictionary.
These are like the most general sentiment dictionaries that have been used in academia.
Yeah, so this is like the most popular one they have. I think it's called BERT for sentiment, but there's like a lot of different ones that you can use. Not all of them are compatible to like easily add in our pipeline. We have a few for each type of LLM. but with a bit of extra code, you could add any model you want to it. Great, then I think we are in time. I will be there later for other questions and we'll share the slides. And this time we're also trying to record it and add it to our YouTube channel. So if that works, see, then you can watch it there as well. So.